Okay, now let us move on to divisibility rules. Divisibility rules. Okay, the logic behind this divisibility rule completely we have discussed in the reminder session. So here I'll be going for a quick recap of what we have done only. So I'm just summarizing here the complete logic we have already discussed, why the divisibility rules are working, etc. But if it is required for some complex numbers, I'll try to explain the logic again also. So let's start. Most of you know all the divisibility rules except a few divisibility rules. Let's see that also, like 7, 13, 17, 37, etc. Okay, 11 everybody know. So I've seen some questions based on 37. Okay, generally they used to ask about 37. So we'll see what is the divisibility rule of 37, 7, 13, 17 and how it is working also. We'll try to see. Okay, let's start off with 2. What is the divisibility rule of 2? You will check the last digit. Okay, last digit you will check whether it is even number or odd number. So if any number is given like a raised to x divided by 2, what is the remainder? Okay, you will just check the last digit. If it is even, okay, 0. If it is odd, 1. Okay, nobody will ask you that kind of questions. Okay, let's move on to 3. What is the divisibility rule of 3? You will check for sum of digits. The reason, the logic, everything that we have discussed on the basis of base 10 concept, right? So sum of digits must be divisible by 3, right? If the sum of digits of numbers is divisible by 3, then that number will be divisible by 3. Let's take 334. What you will do? 3 plus 3, 6. 6 plus 4, 10. Okay, so 10 means it's not divisible by 3. Right? So this number is also not divisible by 3. So if they ask you what is the next number which is divisible by 3, this 10 must be 12. Okay, how can you make it 12? You make it as 6. So 336 will be the next number which is divisible by 3. Or what is the previous number? This 10 must be 9. How will you make it 9? This has to be 3. Okay, so previous number is 333, next number will be 336. Like that, lower level you can get questions. Now 4, last 2 digits, right? You check for last 2 digits, whatever be the number, you only check for the last 2 digits. Let's take 3, 1, 2, 4, 7, 8, 1, 2, 8, 7 divided by 4. What is the remainder? Will you divide all the number completely? No, what I'll do is I'll check what is the remainder when 87 divided by 4. I get 3. So 3 will be the remainder when the bigger number when it is divided by 4. Okay, so I'll only check for last 2 digits. The logic also we have covered in the reminder session. What about 5? 5 you will check for last digit, right? Last digit must be 0 or 5. Any other number if you get, you can find the remainder. So we'll check for, it's a bigger number, 3184 8238 7 is the last digit. You know that it is not divisible by 5. What is the remainder? When divided by 5, what is the remainder? Remainder you will get last digit divided by 5. You will get 2. Okay, what if this last digit is 3? Then remainder is 3. If last digit is greater than 5, divide by 5. If last digit is less than 5, directly write that as a remainder. What about divisibility of 6? This is 3 into 2. So you have to check whether the number is divisible by 3. You have to check whether the number is divisible by 2. So if both are satisfied, then that number will be divisible by 6. You know how the divisibility rule of 3 and divisibility rule of 2, right? This is sum of digits and this is even number. So if a number need to be divisible by 6 means it has to be an even number, at the same time the sum of the digits must be divisible by 3, right? So let's take example 31876. Just add, okay? 3 plus 1 4, 4 plus 8 12, 12 plus 7 19, 19 plus 6 25. 25 means you get 25. Okay, so 25 you need to check divided by 3 or not. No, so this number is not divisible by 3. So it is not divisible by 6 also, although it's an even number. Okay, so if they ask you what will be the next number after this number which is divisible by 6. Okay, so I am looking for an even number. At the same time, I am looking for a number divisible by 3. So when I took the sum, I got 25. So what I need to do, had it been 27, right? Had it been 27, that number is divisible by 3. Okay, so how to make this as 27? You increase 2 here, so this will become 8. Now since this is 8, it is an even number also. So this number is an even number, it is divisible by 3 because sum of digits you are getting 27. So this number is divisible by 6. Or they can ask you what is the previous number which is divisible by 3, right? So you know this is 6, next number we anyway understood 8, so reduce 4, right? You will get 31872. 31872. They can also ask you what is the remainder. Remainder is, you can directly write 4. right? You are just taking the difference only, and you can, based on that difference, see here you understood 25 is what you are getting, right? So 25 means it's not divisible by 3. Okay, had it been 24, okay, had it been 24, it is divisible by 3. So how to make it 24? The 6 become 5. But what is the problem? It's an odd number. It's an odd number. Odd number but divisible by 3. That is not divisible by 6. So what I need to do is I need to subtract 3 again. Then I'll get this number. So it's an even number, it is divisible by 3. So I understood that 4 is the remainder. Next, 7 I will discuss after some time. 7 I will discuss along with 13, 11, 17 and 37. This all will discuss together. Let's see 8. What is the divisibility of 8? Last 3 digits. Last 3 digits, right? So if you see 2, last digit, 4, last 2 digit, 8, last 3 digits, 16 will be, if you follow this, last 4 digits. Why? This is 2 raised to 1, 2 square, 2 cube, 2 raised to 4, right? Now what about 9? 9 is similar to 3. What you will do, you will take sum of digits, okay? You will take sum of digits and you will check whether it is divisible by 9. So let's take 3, 1, 8, 7, 6, okay? Again, 3, 1, 3 plus 1, 4, 4 plus 8, 12, 12 plus 7, 19, 19 plus 6, 25. You will have to check whether this number is divisible by 9 or not. So not. It is not divisible by 9. This is not divisible by 9. And what is the remainder? You can divide 25 by 9 and you will get it as 7 as a remainder. But we have a very different method also for 9. In case of 9, when you take sum of digits, you take sum of digits till you get a single digit. That means here you got 25. Again you find sum, okay? So you will get 7. Now what are the possibilities? Because you are trying to find single digit, right? So what are the possibilities? 1, 2, 3, 4, 5, 6 up to 9. These are the possible numbers. 0 you won't get because you are taking sum, okay? So 1, 2, 3 up to 9 is the possibility. Now if you are getting 9 when you take sum of digits, that number is divisible by 9. If you are getting any other digit, what is that? That is the remainder when you divide that number by 9. So here when you took the sum of digits till you get a single digit, what you got is 7. What does it mean? It means 7 is the remainder when you divide this number by 9. That is what exactly we found here also. 7 is the remainder when you divide that number by 9. Okay. So what you have done nothing but 3, 1, 8, 7, 6, 7, 6. Okay. So we are finding the sum. So 3 plus 1, 4, 4 plus 8, 12, 12, 19, 25, 32, 38, right? So we got 38. Further what you need to do, you find the sum. 3 plus 8, 11. Now still you need to find it 2. So when you find the sum of digits of this number till you get a single digit, what you got? You got 2. What does this mean? Firstly, you are not getting 9. That means number is not divisible by 9. Secondly, you got 2. What does this mean is when you divide this bigger number by 9, the remainder that you are going to get is 2. So you can conclude that 2 extras there from a multiple of 9. That is what you mean by remainder. So they can frame a question here. They will give you a number like this. They will ask you what is the next multiple of 9 or what is the previous multiple of 9 compared to this number. So if it is previous multiple, you just subtract 2, you'll get 4. If it is next multiple, how much more you need? You have 2 extra. How much more you need? You need 7 more, right? So you will add that. So it was 76, you add 7 more, you'll get 83. Now if you see the sum, 3, 4, okay, 12, 19, 25, now 83, right? 25 and 8, 33, 33 plus 3, 36. So 36. Now you take the sum, you'll get 9. What does this mean? Number is divisible by 9. So what you're doing, you had 2 extra, you're adding 7 more. You'll get the next multiple of 9. You had 2 extra, you subtract that 2, you get the previous multiple of 9. Okay. Now based on this, you can get different types of questions. We will discuss all the questions when it comes to the problem solving sessions. Now I'm just discussing about the divisibility rule only. Okay. Okay. Now let's move on to 10. Let's move on to 10. What is the divisibility of 10? 2 into 5. Why? What is the logic? 10 raised to x by what will give you a remainder 0? Okay, this is what we are actually trying to find out. We had discussed this in factorials, we had discussed it in reminders and everywhere. So it has to be 2 and 5. Okay, so it has to be 2 and 5. That's the reason why you are checking for 2 and 5, right? So divisibility of 10 means you have to get 2 and 5. 12, 3 into 4, 13 we'll see, 14, 7 into 2, 7 we'll discuss, 15, 5 into 3, 16, we have already discussed, last 4 digits, right? Last 4 digits. Now you don't want to have any confusion. 8 I have already told you, last 3 digits, right? What does it mean? You may get a 1, 2, 8, 3, 7, 6, 1, 2, 6, 1, 2, 6. This is a bigger number. Divide by 8, what is the remainder? It's just a calculation question, but what we need to do is, we'll just take the, if you know the divisibility rule, take the last 3 digits, right? Now you know 120 is divisible by 8, so what is the remainder? 6 is a remainder. What does this mean? When I divide 126, I get a 6 as a remainder. That itself will be that remainder will be the same as that of, if you divide bigger number with 8, then also you'll get the same remainder. If you divide this bigger number by 8, you will get 6. If you divide this 3 digits by 6, then also you'll get 6 only. If you divide 126 by 8, then also you'll get 6 only. Okay, so rather than dividing the bigger number, you can take the last 3 digits and you can get the remainder. That is the use of divisibility rule. Next is divisibility of 7. Okay, so in case of 7, what we need to do is, okay, let's take a number 200, 300, 250, 350. Okay, so what we need to do here is we need to divide this number into triplets. Okay, from the rightmost side. Why we are doing this is because we know that 10 raised to 3 by 7 is equal to minus 1, and 10 raised to 6 by 7, which is equal to 1. Okay, so and it is like it will go on like that. 10 raised to 9, if you see, it will be minus 1. 10 raised to 12 will be plus 1, 10 raised to 15 minus 1, 10 raised to 18 plus 1, and etc., which is going on. And here basically we are applying this basic remainder theorem only, which we have already discussed it in reminders. So what we are going to do here is, we'll group it into triplets from the rightmost side like this. So you got 4 equal groups. Now if you are not getting a perfect group here, it doesn't matter, it's not a problem. Okay, so whatever is possible, you group it into triplets from the rightmost side. If it is 1 digit remaining here, not a problem. Okay, you can keep it as such. Let's suppose if the number is like something like 3334. Okay, this is the only group which is possible, so you'll group it in this way only. Then after this, you put plus minus signs alternatively, right? And then you bring the same signs together just like this. So you will get 650 minus 450, which is equal to 200, right? Now this 200 you divide manually by 7, okay, and see what is the remainder. What you will get is 4. Okay, so basically what I want to tell you is, your questions will be like this. You have a bigger number, divide by 7, see what is the remainder. What you're doing this only, you're grouping into triplets from the rightmost side, putting plus minus signs alternatively, right? And then you group the plus signs together and the minus signs together, and then you get a 3-digit number finally. So divide that 3-digit number manually by 7 and see what is the remainder. The idea is, if you divide this bigger number by 7 and if you divide this 3-digit number by 7, you're going to get the same remainder. So rather than dividing the bigger number, it's always better to divide the 3-digit number to get the remainder faster. So this is a remainder question which can be asked again based on the divisibility rule of 7. Okay, so what you are doing is nothing but grouping into triplets from the rightmost side, put plus minus signs alternatively, bring it into 3-digit number, divide it manually by 7, see what is the remainder. The 3-digit number divided by 7, what the remainder that you are getting will be the same as that of the bigger number if you divide by 7, the remainder. Or if you want, let's take a small number like 1141. Okay, so divide by 7, what is the remainder? This is just a small number to check, right? So what you will do, you will divide it into a group of 3, so you can only get one group, right? Or let's take this as 142. Okay, 1142. You'll get only one triplet. So what you need to do, you will divide it like this only. 142 minus 1, you will get 141. So basically what I'm doing is I'm converting this 4-digit number into a 3-digit number. You divide by 7, see what is the remainder. Okay, you will get 1 as a remainder. 140 will go, right? So 1 as a remainder here. The point which I need to tell you is, if you divide this bigger number by 7 and if you divide this 3-digit number by 7, you're going to get 1 as a remainder. Okay, so rather than dividing the bigger number, we divide the small number. So basically you need to understand how you're converting the bigger number into a 3-digit number and then how you're dividing it, right? And same as the divisibility rule of 13, except the last step, where the last step is you need to divide by 13 manually. Okay, why this is working is because 10 raised to 3 divided by 13 is equal to minus 1. 10 raised to 6 divided by 13 is equal to plus 1. Similar to that of 7. Okay, so that's why same rule. We are dividing into group of triplets and putting plus minus alternatively, right? 10 raised to 9 by 13, again you get minus 1. 10 raised to 12 by 13, you will get plus 1. Okay, now what do you mean by this minus 1? When I say there is no point of minus remainder, right? So what does it mean? So minus 1 means basically you subtract 1 from 13. You get actually 12 is the remainder. That means 988 is divisible by 13. What is left out is 12. That's why you are writing it as minus 1. Okay. So what is the divisibility rule of 3? You again, it is similar to that of 7. You divide into group of triplets, put plus minus signs alternately. Finally you get a 3 digit, you divide it manually by 13. If you want, we can take the same example. Let's take 200, 300, 250, 350, right? You divide into group of triplets, plus minus signs alternately. You get 650 and you get 450. So if you take the difference, you will get 200, right? Now 200 you divide manually by 13 and see what is the remainder. What you get? You get it as 5, right? So what does it mean? If you divide the bigger number, if you divide this bigger number with 13, and if you see what is the remainder, and if you divide the smaller number by 13 and if you see what is the remainder, both will be same as, and which is 5, right? So rather than dividing the bigger number, you can divide the small number. Now if you want to try a small number, you can take this number 3134, right? Divide by 13. What is the remainder? You can do it manually also, but we'll try to see how you can bring it into 3-digit number, right? So what you will do, you will group into triplets. You got only one triplet. This is plus minus. So 134 minus 3, you will get 131 divided by 13. You get remainder is equal to 1. What does it mean? If you divide the bigger number by 13 and if you divide 131 by 13, both are going to give you the same remainder. So rather than dividing the bigger number, always divide the small number, which will be more convenient and more easy for you. Okay. Now what about 11? 11 is a special case where you have enough flexibility. You can take it into a group of 1, you can take it into a group of 3, 5, 7, 9, or whatever you want, you can take it, right? So you will take, if it is 1 to 1, you will divide into a group of 3 and plus minus signs alternately, and you add 2 minus 2 is equal to 0. So it should be either 0 or divisible by 11, right? Okay, why is it like this? You already know 10 raised to 0 is equal to, you will get a remainder 1. 10 raised to 1, you will get 10 raised to 1 means 10 by 11, you will get remainder minus 1, right? Because actually your remainder is 10, but you write it as minus 1. 10 square by 10, you know you will get it as 1. 10 cube by 11, you will get it as minus 1. 10 raised to 4, you will get it as plus 1. 10 raised to 5, you will get it as minus 1. Okay, so alternately it will be like this, right? Okay, now what about 17? 17, see, 10 raised to 8 by 7 will give you a remainder of minus 1. So this is what we are going to apply. Okay, so 10 raised to 8 by 17 will give you a remainder minus 1, then plus, then minus, then plus, etc. So we are going to group it into a group of 8. Then we put plus minus signs alternately. Okay, similar approach. So we understood that 10 raised to 8 by 17 will give you remainder 1. We have discussed it in the reminder session. So we are going to apply it. So we'll divide into group of 8. Okay, group of 8. This is also group of 8. This is also group of 8. Put plus minus signs alternately and bring it into a group of 8 and you can solve it faster, whatever be the bigger number. Now the repeated questions which I have seen is in case of 37. The logic is 10 raised to 3 by 37 is equal to plus 1. Okay, 10 raised to 6 by 37 is also plus 1. So it will go on like that. So here we have only plus. We have only plus, that is what you need to keep in mind. There is no alternate change. So whatever bigger number you're going to get 1, 2, 3, like 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. What you will do? 1, 1, 1. Okay, so all are plus. This is plus, this is plus, this is plus, this is plus. So there is no point in taking difference. So how many groups are there? 4 groups are there. You need to know what is this 4 group. 123 into 4 is what you need to do. Okay, and then that number you need to divide by 37 and see what is the remainder. Okay, 123 into 4. So basically you need to divide 592 divided by 37. See what is the remainder. Rather than doing this, what is this 592? 123 into 4. Why this 4? Because 4 pluses are there. Okay, let me take a question with that. I can explain everything. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3 up to 300 digits. Okay, so you have 300 digits means how many 1, 2, 3s? You have 100 1, 2, 3s. 100 such groups, that means total 300 digits. Okay, so I can ask you, let's take this as n. N is this. So I can ask you n by 2, what is the remainder? N by 2, what is the remainder? What is the divisibility of 2? You will check the last digit is 3, so your remainder is 1. N by 3, what is the remainder? You need to find sum of digits, right? So if you take sum of digits, 1, 2, 3, okay, is the sum of digits of one group, so you'll get 6. 100 such groups are there, so 600 is divisible by 3, so sum is 0. N by 4, if it is n by 4, last two digits here is 23, so your remainder is 3. You will check 23 by 3, what is the 23 by 4, what is the remainder? 3, right? N by 5, you check the last digit, it is 3, so it is also 3. N by 5, remainder is 3. What is n by 6 remainder? N by 6 remainder, see, you need to check whether it is an even number. It's not an even number, it's an odd number, so it is not divisible by 6. Then what you need to do is, you need to check whether it is divisible by 3, right? So it is divisible by 3, but it is an odd number. So what we need to do is, what we can understand is, it is divisible by 3, okay? The divisibility rule of 6 is it should be divisible by 3 and it should be an even number. So if you take the previous number, right, that means 123, 123, 123, etc. ending in 120, it is an even number at the same time. This is divisible by 3. So this will be divisible by 6. But what is our number? Our number is 123. So how much extra is there? That is your remainder, that is 3. So 3 is your remainder. So what you have done is, 123 I understood that it is divisible by 3, but it is not divisible by 2. So I am taking 3 as the remainder. Why? Because 120 is a number which is divisible by 3 and 2 and which is divisible by 6. Okay. Now what about 7? 7 we have already discussed, right? You will group it into a group of triplets. So you'll get 100 triplets, 50 plus, 50 minus. So if you take sum and if you take the difference, you'll get 0. So if you take n by 7 remainder, it is 0. What is n by 8 remainder? 123 by 8, right? So you'll get remainder 3. You will get remainder 3. Now 9. 9 is interesting, right? What is 9? You will get sum of digits. You will till you get a single digit, right? So n by 9. If you need to find remainder, you will get sum of digit till you get single digit. And if you get 9, that is divisible by 9, then remainder is 0. If you get any other digits in 1 to 8, that is your remainder when the number is divided by 9, right? So here 1, 2, 3 will give you 6. 100 such groups are there, so you'll get sum as 600. Again you take sum of digits, you'll get 6. What does it mean? 6 is the remainder when you divide this bigger number by 9. Now what if the number is divisible by 10? Easy, you will write the last digit 3, right? Now what if the number is divisible by 11 remainder? N by 11, what is the remainder? You will, here I told you for 11 you have enough flexibility, you can group it into a group of 1, 3, 5, 7, 9 or whatever you want, right? So here you will group it into a group of 3, so it will be easy, right? So you'll get 50 positive group and 50 negative group, it will be cancelled out. So 11 also you'll get remainder 0. 11 also you will get remainder 0. What if n by 13 remainder? The same approach that of 7 and 11 we will do. We will group it into triplets and put plus minus signs. You'll get 50 plus groups and 50 minus groups, so it will be cancelled out, right? So here also you'll get remainder 0. What about 37? N by 37, if you need to see the remainder, here you will group it into a group of 3, then put only plus signs, right? So how many such groups are there? 100 groups are there with 1, 2, 3, right? So each group is 1, 2, 3. So your sum will be 1, 2, 3, 0, 0. This you need to divide by 37, right? Again what you can do, you can apply the same formula. You can just split it into group of 3. So you'll get this both you need to add. So 300 plus 12, 312 divided by 37, you need to see what is the remainder. So basically the bigger number divided by 37, what is the remainder will be similar to that of 312 by 37, what is the remainder? What you will get? You will get it as 16. So I hope all of you are clear with all the divisibility rules. So quickly, if you want to go for a quick recap, what is divisibility of 2? Last digit, right? Divisibility of 3, sum of digits. Divisibility of 4, last two digits. Divisibility of 5, last digit is either 0 or 5. What is divisibility of 6? 3 into 2. Okay. What is divisibility of 7? Here you need to group it into a group of triplets on the rightmost side. Put plus minus signs alternatively. Bring together with the same signs and take the difference across. Then you get the 3-digit number. Divide the 3-digit number manually by 7 and see what is the remainder. If you get a remainder question. Divisibility rule of 8. You take the last 3 digits. Right? And check whether it is divisible by 8 or not. Divisibility rule of 9. You take sum of digits till you get a single digit. So this can be asked as a digit sum question, or digit sum means sum of digits till you get a single digit, right? Or it can be asked as an AP with a common difference of 9. AP with a common difference of 9. The question can be something like you have a number x. Okay, in the first step you take the sum of digits, second step you take the sum of digits, and finally you got a number. Okay, let's say 5. How many such possible numbers are there? How many such possible numbers are there? Okay, within a range of 1000 or something. Okay, so you'll start with 5. 5 is the first number, then 14, right? Then 23, right? Like that it will go. You keep on adding, then 32, then 41, etc. You keep on adding 9, right? So you keep on adding 9. So this is basically an AP with a common difference of 9. So basically they can ask you from 1 to 100 how many such terms are there. So you know the first term. Okay, you can find the last term also based on this, and you can get the number of terms. We have already discussed all these things in AP and division questions. Everywhere we have covered this, right? What are the possible question? What is the first possible number? What is the next possible number? What is the nth possible number? How many such possible numbers are there? All can be asked here, okay? Because it's an AP. Now, what about the divisibility of 10? You'll check for the last digit. It should be 0. Otherwise, that will be the remainder and divided by 10, right? What is the divisibility of 11? 11, you have enough flexibility. You can group it into a group of 1, 3, 5, 7, 9, or whatever you want. The way you want, you can group, right? Now, what about divisibility of 13? Similar to 7, you group it into a group of triplet, and see, you put the plus minus signs alternately and bring together, take the difference, right? And you get a 3-digit number, divide it manually by 13, see what is the remainder. What about the divisibility of 7? You will group it into a group of 8 and put plus minus signs alternately. What about divisibility of 37? You group it into a group of 3. That means you find the triplets, put plus signs only. How many such triplets are there? You add everything and you get a number that you divide manually by 37 and see what is the remainder.